Hello dear learners, in this video we are going to study in detail about chi-square test as a non-parametric test. Now let us start with the lecture. So what is chi-square test? Chi-square test is an important test amongst the several tests of a significance developed by statistician. A chi-square, symbolically it is denoted by this chi-square, this symbol, pronounced as a chi-square. Is a statistical measure. It is used in context of a sampling analysis for comparing a variance to a theoretical variance when we are going to use this test. So as a non-parametric test, it can be used to determine if categorical data shows dependency, or we can say the two classifications are independent. Then we have to use this test as a non-parametric test. Now it is a technique through the use of which it is possible for all researchers to test the goodness of fit, to test the significance of association between two attributes, as well as we can say to test homogeneity, or we can say significance of population variance. Now we will see the equation. So the test for comparing variance, to compare variance we have to apply this equation. So when we have to use chi-square test as a test of population variance, we have to work out the value of chi-square to test the null hypothesis by using this equation. When we have to use this equation? When we are applying this test of a population variance. Then we have to use this equation, where what is this SS square means sigma S square means variance of sample. Then SP square means variance of population. N minus 1 means degree of freedom. So N being the number of items in the sample. Now the next is problem. Now we will see the problem. So here is the problem. Weight of 10 student is given over here. This is the serial number of the student and this is the weight of student in kg. Now what we have to do? So can we say that a variance of distribution of weight of all students from which the above sample of 10 students was drawn is equal to 20 kgs, and this test this as a 5% and 1% level of significance. So how we can measure it? First of all, we should work out the variance of the sample data, or SS square, and the same has been worked out as under. So here the x1 means a weight in kgs, the x minus x bar and the square of it. So here the serial number. So here the serial number is given 1 to 10, the sample number student we can say, then weight of that in kgs. Now this minus x bar means these are the values of that. It is a 470 and this is the square. So we are getting this value. After that we have to put that equation. So first of all we have to calculate the s square. So how we can calculate it? From this equation, as we know already, we have to first find the x bar. After that we have to find this sigma s means a standard deviation of sample and its square. After getting this, what we have to do? We have to put the equation. This equation we have to put and we will get this value. Now degree of freedom in the given case, this one is equal to 9. As we know that it's a 10, number of item is 10. So the degree of freedom is 9 at a 5% level of significance. The table value is this much. This is the chi-square value, and at 1% level the value is this. So both of these values are greater than the calculated value. That's why we are accepting the null hypothesis. This is very simple example. Just we have to put the equation and we will get the value of chi-square test, and from the table value we can say it is accepted or rejected. Now the next is conditions for applications of chi-square test. Now when we can apply the chi-square test, what are the conditions? So when observations recorded and used are collected on a random basis. When we are collecting are observations, or we can say we are using it or collecting it randomly when all the items in the sample must be independent. No group should contain very few items, means less than 10. We cannot apply this test for this much less than 10 items. The overall number of items must also be reasonably large, and the constraints must be linear. Constraints which involve linear equations in the cell frequencies of a contingency table. Now we will see the steps for chi-square test. Steps for applying chi-square test to solve the problem. What we have to do? So first of all, we have to calculate the expected frequency on the basis of given hypothesis or on the basis of null hypothesis. So usually in case of 2 into 2 or any contingency table, the expected frequency for any given cell is work under table. So expected frequency of any cell we can calculate it by the row total for the row of the cell into column total for the column of the cell divided by grand total. After obtaining this, we are getting this value. So obtain the difference between observed and expected frequency and find the squares of such differences. So we have to calculate this. Square of this O minus E means observed minus expected frequency. This is the second step. After that, divide the quantity obtained as stated above by the corresponding expected frequency to get this. Means we have to divide it by this value, and this should be done for all and cell frequencies or the group frequencies. After that, find the summation of this, or what we call this equation we have to put summation. Now this is the required chi-square value. So the chi-square value obtained as such should be compared with a relevant table value of this, then interference be drawn as stated above. Now we will see how we can calculate it, the second problem. So here what we have to find? We have to find the value of chi-square from the following information. So what we have? We have the observed frequency as well as the theoretical, or we can say expected frequency. So these are the number of items, 5 number of items is there. These are the observed frequency and this is the expected frequency. So we can directly put the equation. Since some of the frequencies less than 10, we shall first regroup the given data and then we'll work out the value of test, because here we are getting frequency less than 10, that's why. So what we have to do? We have to plus this frequency with the higher frequency. So A and B, we are making over here 3 groups, A and B, C and D and E. There is no need for C because it's already 44 and 38 over here. So we are making the group like this and we are getting this value in this 3 group. Now we have to minus this O minus E means observed frequency minus expected. So we are getting this result 37 minus 31, this and this result like this. Now we have to divide it by this expected frequency. So we are getting this result, right? Now we have to put the value in this equation and approximately we are getting this value. So this is all about the non-parametric test as a chi-square test. Thank you dear learners for watching the video.